So traversing the winter sky together, the next of our purple or special objects that we're going to talk about is down in Orion. So look at the normal hourglass shape of Orion down there, the asterism. And if you were to imagine a sword hanging from his belt, the tip of that sword would be this little spot right here where it looks like a star, right in the middle of his skirt of his toga. And we're going to circle that because it's much more than just a star. And it makes for a fantastic binocular object or a small telescope object if you have access to either one. And it also fooled Charles Messier, so he thought it was a comet initially, and hence it got the number 42, the 42nd item of his 110 object catalog of things that are definitely not comets. M42 is gorgeous through long exposure photography. You can get it to look like this with all that coloration to it, all that pink and all that red. This is actually a digital photograph, but you know, it's been enhanced and photoshopped, if you will, and really brings out the colors that you would see if you could just stare at it for an hour and let your eyes pick up all the color that kept coming to you. But you and I through a telescope see this mostly as gray. It looks very, vaporous and very cloudy, but we don't get to see the colors unless you really capture it on some sort of detector, some sort of a photograph. So it's called the Orion Nebula, a good name for it, or sometimes the Great Orion Nebula. It's just so big and so famous. Either one is the same though, M42. And it is your prototypical emission nebula. If you've already done the summer sky chart, you've already been introduced to some emission nebulae. If you're doing the winter chart for the first time, then this is the first time you've seen an emission nebula. Emission nebulae, there's plural for nebula, are always reddish in color. They emit so much red light. That's where the name emission nebula comes from. And every single one of them is doing the exact same thing. They're all big stellar nurseries. Young stars being born within that huge cloud, probably 100 at least at a time. So a stellar nursery, a whole lot of baby stars in one specific area. We think our sun was born the exact same way, out of an emission nebula over 5 billion years ago, with 99 brothers and sisters around us. So these days, now that our galaxy has collapsed into its pancake shape, we're quite certain that all stars these days are born in emission nebulae inside of the pancake, looking kind of like chocolate chips every so often in the pancake, these emission nebulae, regions of star birth. Well, that's already a pretty gorgeous shot there, and I see all sorts of filamentary structure. I see the cloudiness, I see the tendrils of gas, I see some dust in there too, some darkness in the center. And embedded in the brightest part, rather, right here, is an open star cluster. So it's trying to blister its way out. And if you just hit the fast forward button, about 100 million years in the future, all this gas and dust would then be gone. It would have been used up in making stars or have been blown away by the brand new stars, either one. It would expose the open star cluster in the center of it. So let me show you another spectacular image of this. It's even bigger. It's kind of edge to edge, so it'll take your breath away, I hope. And this just shows, wow, look at all that filamentary structure, all that gaseous material. That's what a nebula is, a big cloud of gas and dust. And the open star cluster is right here. My cursor is circling it for you, right embedded in the middle, the brightest part. And you can imagine this cloud looking like a cupped hand. It looks like this in my little window here, a cupped hand. And just because of where we are in the galaxy, we're on the side of the nebula where the stars are going to blister out of. So we're seeing the show. These stars are going to march their way out of this nebula in, tens of millions of years in the future. But all that gas, all that dust, just gorgeous when you get this long exposure photography from this area. Charles thought this looked like a nebula, so he called it M42, the big red portion. And the portion down below, he called it M43. He had no idea that these two were just, linked. You can see the mass bridge between them, can't you, in this photograph? But it was hard to tell, of course, 400 years ago in a crude telescope. So that's a gorgeous shot already, digital photography. And then there's this one that's even, even a bit more jaw-dropping, quite frankly. This one really accentuates the redness of the nebula. And if there was ever a term for Valentine's Day red, I think that's it. My goodness, that is red. And it's hard to tell what you're looking at here. But over on the right-hand side is the image you were just looking at. M42 is right here that I'm circling with my cursor. M43 is right here. And then there's this huge link of mass over to, do you see what I see down there? That's the Horsehead Nebula down there. You've already seen that in one of my dusty photographs. And these two bright bluish-white stars are actually two of the stars of Orion's belt. The third star is just off the edge of the photograph, right about where my cursor is circling right over here. So this is Orion's skirt turned on its side. And look at all that gas and dust and all that raw star-making material that lies in that direction. So, you know, you're already kind of partial to Orion because he's just so gorgeous with the asterism. But boy, with long exposure photography, there's all sorts of celestial delights to look at with a small telescope or a pair of binoculars in Orion's direction. So check him out if you can. So if this is your first encounter with an emission nebula, let me show you a couple more. Okay, maybe four more. Here's another one. Big red cloud of gas and dust. This is a digital photograph taken by the Canada-France-Hawaii telescope, CFH for short. It's on the big island of Hawaii up at the top of Mauna Kea. And, you know, with digital photography, you don't get to see nearly the accentuated color that old photographic film would pick up, which is very, very sensitive to red light. But I still see some reddish hue there. It was trying to make it, you know, basically visually correct. And I see this dark cloudiness in the middle. This is actually dust blocking out light there. And it looks kind of like an eagle with his talon right here. Yes, his foot on the branch, and there's his body, and there's his wing right here, maybe. So that's where I got the name, the Eagle Nebula, from. Or maybe you saw the larger eagle with his head way up here and his wing one down below and one up high. Yeah, but either way, it definitely looks kind of like an Eagle Nebula. Not too far away from M8 and M20 down on the teapot in the summer sky chart. Next, another digital photograph. Take a look at this one. Pretty sexy name up top there, NGC 281. NGC stands for the New General Catalog of Non-Stellar Objects. So, you know, it's a huge catalog of just that numbered items. This is 281. But what I like about the photo is that I definitely see the reddish hue of the emission nebula. But I also see the soot. I also see the opacity, the opaque dust over here on the right. And that just hasn't been illuminated yet. This is the raw materials for making stars. And all that condenses and you start to form a star, it'll brighten up and become this very bright area like you see now. So marching forward, this gas cloud will eat its way into the darker area and start making more and more stars out of this raw materials that are on the right-hand side. So it's kind of nice to see the actual process of star formation in a large emission nebula like this one. The next one I'm going to show you is done with old photographic film, which is very sensitive to red light. Yeah, look at that eye-popping pinkish red. We call this one the North American Nebula. I give Dominic his full credit down here. And if you know your continents, you know that's the east coast of North America over here. There's Florida. There's the Gulf of Mexico right there. There's the Yucatan Peninsula. There's Mexico. There's the west coast of the United States on the left. You know, it vaguely resembles North America, the continent. So that's how it got the name. Not too far from Cygnus in the summer sky. Gorgeous. And one more with just a photographic film, the old silver nitrate surface. And this one's called this is the Omega Nebula, yes. And this one here looks an awful lot like looks like a donut, doesn't it? Not to be confused with a planetary nebula when you learn about that. But this is just your archetypical emission nebula, all nice and red, with stars being born inside of that the tendrils of gas. And these brighter stars in the center here, they're just in the foreground. They're closer to you than that nebula that's behind. But all emission nebula, big, large clouds of red gas and dust, and all of them giving birth to stars. There's your test question. So M42 just might be the most famous of them all, of all the emission nebulae, and that's why we're talking about it here. Okay. All right. On to the next one.